Recording has started.
So, starting Unit 3. Unit 3 is, this is the word I know that everybody dreads hearing, but it's our algebra unit. We talked last Friday about some of the basic uses of variables. And we translated some phrases into those algebraic sentences and expressions. Did anybody have any questions off the homework from last Friday that they want to go over before we get into anything new? Everybody's good? Okay. So today we're going to look at a couple other uses for the variables, but we'll review a little bit here. Let's say we have an object like this, where this dimension is given as 9x. This dimension here is given as 3y. And I want to write an expression for that dimension there. Well, the simplest way to write that expression is to just say if this were a number and this were a number, I would be subtracting the two to get that length. Well, even though they're not numbers, I'm still going to subtract them. The expression for that length is simply going to be 9x minus 3y. I might have something like this, where this is listed as 4a, and this is listed as 5b. If I want an expression for the distance from center to center of those circles, well, here, if I had numbers for each of those, to find that distance, I would be adding them together. With the variables, I'm going to do the same thing. It's just 4a plus 5b. Well, in both of these cases, all it was a matter of putting the two things together and putting in the appropriate operation. There was nothing that can be combined. However, when we're dealing with algebraic numbers, just like any other number, we follow the rules for basic addition and subtraction and multiplication and division. Remember, when we add or subtract, we need the same name. Up here, none of these had the same name. 9x and 3y are different names. We couldn't combine them any further than to just put the operation between them. 4a and 5b have different names. One is an a and the other is a b. So we couldn't combine them any further other than to just put the operation, the addition in between them. We combine counts, and then we keep the same name. When we multiply or divide, we do not need the same name. So if any of these up above would have been multiplication, we would have still been able to combine them even though they have different names. We combine counts. And then we also combine the names. So let's look at some examples here. Let's say Then instead of having different names here, this dimension is given as 11x. And this dimension here is given as 7x. How do I find this dimension here? Well, just like before, it's this one minus this one. So now 11x minus 7x, we can combine the counts. 11 minus 7 is 4, and we keep the same name of x. Or in a situation like this, we might have 5a and 3a. If I want to know that distance center to center, I'm going to be adding them again, 5a and 3a. But now since they have the same names, I combine the counts. 5 plus 3 is 8, and I keep the same name. They're both a, so that stays a. For multiplication, let's say that this radius is given as 7m. And I want to know the diameter. Well, to find the diameter, it's the radius. Diameter equals 2 times the radius. So to find that diameter, it's 2 times the 7m. Well, those have different names, but it doesn't matter because we're multiplying. Now, it's pretty obvious here that the name here on the algebraic part, the 7m, that name is m. On the 2, the name isn't quite so apparent, but that's really just 2 ones. Remember, the place value of a number, of a regular whole number, the place value is its name. So when I multiply those out, I combine the counts. 2 times 7 is 14. Then I also combine the names. 1s times m, well, anything times 1 is itself, so that's just m. I might have something like this that is 4x by 7y if I want to find the area of that. Remember, area is length times width, 7y times 4x. Well, I'm going to combine my counts. 7 times 4 is 28. Then I also combine the names. Y times x could be thought of as yx or xy. Math grammar, there is actually such a thing as grammar in math, tells us that when we have two variables, it's most proper to list them in alphabetical order. So xy, 28xy. If you said 28yx, it would not be wrong. It's just poor grammar. I would still count it as okay, but we should put them in alphabetical order. Or we might have something like this that is 3p in width, and we're told that the area is 18p squared. If I want to find the length, it's going to be the area divided by the width. 18p squared divided by 3p. So 18 divided by 3 is 6. P squared divided by p is just p. do much more combining our variables, we have to talk briefly about some rules of exponents. Because our variables have powers on them, if we just see x, that really means it's equivalent to x to the power of 1. We don't write it there because we don't need to, but it is there, and when we do operations with it, we have to understand that 1 is there. Technically, there's also a 1 like this. X is also just 1 times x, or 1x. We don't need to put that 1 in there either, but we need to know it's there when we go to do operations with it. If I have 7x plus x, it makes more sense if we realize that's a 1x. We combine count, 7 plus 1 is 8, and we keep the same name of x. If I, of course, have x to the third, means 3 x's multiplied together. We've briefly looked at that before. But what if I have more than one exponent? Remember, an exponent has two parts. In x to the third, the x is the base. That's the number or symbol that we are acting upon. And in this case, the 3 is the power. That's telling us how many times that base is being repeated. So x to the third, x is the base. That's the number that's being acted on, or the number that's going to be repeated. 3, the power, tells us we're repeating it 3 times. So if we have x to the third times x to the fourth, x to the third means 3 x's multiplied together. X to the fourth means 4 x's multiplied together. If I multiply that all together, I now have 7 x's multiplied together. That is x to the seventh. Well, some of you have probably seen a shortcut before. It looks something like this. X to the power of a times x to the power of b just becomes x to the power of a plus b. So if I have x to the seventh times x to the 12th, they have the same base, so I can combine the exponents, the powers. It becomes x to the power of 7 plus 12 is 19. Or I might have y to the 15th times y to the 23rd. Again, they have the same base of y, so we keep the same base. We combine the powers. Y to the 15th times y to the 23rd, 15 plus 23 is 38. So that's y to the 38. If I have z to the fourth times w to the seventh. Those have different bases, z and w. I cannot combine the powers, the exponents there, because I have different bases in my exponents. So z to the fourth, w to the seventh, all we can do is take out the multiplication symbol and put them together. Remember, it's proper to put them in alphabetical order. So we just list that w to the seventh, z to the fourth, without the multiplication symbol. If we're dividing x to the fifth divided by x to the third, x to the fifth, of course, is 5 x's multiplied together. X to the third is 3 x's multiplied together. Just like, remember we said we could go back and forth between division and fractions. They're interchangeable. So putting this division in fraction notation, we can actually cancel out, divide out numerator and denominator like we would with any other fraction. We divide out an x, another x, and a third x, we're left with x squared. Though that illustration even shows us the shortcut there. You may have seen if you have x to the a divided by x to the b, that comes out to be x to the a minus b. X to the 17th divided by x to the 9th comes x to the 17 minus 9 is 8, x to the 8th. Z to the 4th divided by z to the 7th. Here's where you have to be very careful about the order of your exponents. Those both have the same base of z, so we can combine them. It's going to be z, but it's z to the 4th divided by z to the 7th. So it's 4 minus 7 is actually a negative 3. We'll talk in a little bit about what that negative exponent means. And of course, y to the 8th divided by w squared, those have different bases. We cannot combine their exponents. There's nothing more we can do with that. It just stays y to the 8th divided by w to the 2nd. What if we have x to the 4th to the power of 3? That is saying we have 3x to the 4th multiplied together. And of course, each of those x to the 4th is 4x's. If I multiply those all together, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 total x's being multiplied together. That's x to the 12th. Again, you probably know the shortcut. If I have x to the power of a, and that's going to the power of b, that is x to the power of a times b. So x to the 5th, the power of 7, is just x to the power of 5 times 7 is 35. Or y to the 8th to the power of 4, that's y to the power of 8 times 4, or 32. Notice there's only one base there, and there's two powers. So we don't have to worry about matching up the bases, because there is only one base when we have that power of a power. So now with these, we have some things to worry about as far as like x to the power of 0. Now, x to the power of 1 sort of makes sense. It's just a single x there with nothing multiplying. X to the power of 2, of course, means we have two x's multiplied together. X to the 0, though, having no x's, most people would say, well, that's 0. That's nothing. But it can't be. Remember when we talked about multiplying two negatives, we said we had to look for a pattern, and we defined the answer to be what fits that pattern. We have to do a similar thing here. If I look at x to the... Let's look at a number first. It makes more sense to put numbers in here for now. If I do 10 to the power of 3, that's 10 times 10 times 10, or 1,000. 10 to the power of 2 is just 10 times 10, or 100. 10 to the power of 1 is just 10. So what I have done here to establish this pattern is I have 10 as the base of all my exponents. And at each step, I've reduced the power by 1. I went from 3 down to 2, from 2 down to 1. The result, each time I reduced the power by 1, my answer was divided by 10. 1,000 divided by 10 is 100. 100 divided by 10 is 10. So if we continue that pattern, we reduce the power by 1, the answer again has to be divided by 10. 10 divided by 10 is 1. so 10 to the power of 0 has to equal 1. Anything to the power of 0. I could put any number in there, and it would give me a similar pattern. I could put a variable in there, and it would have to follow along. Anything to the power of 0, even x to the power of 0, equals 1. Keep this in mind because I have a little bit of a twisted sense of humor. So at some point, you might see me do something weird like this, where I have something like 73x to the 54th times 24x to the negative 283 over 5x to the 72nd minus 3x to the 64 to the power of 0. What's that equal? 1. Because this is all to the power of 0. And anything to the power of 0 equals 1. I know that's not very nice, but anything to the power of 0 is 1, no matter how complex it is to start out with. So now let's look back at some of our basic algebra functions that we can do with these expressions. We might have something like 3m plus 2p. You might be asked to evaluate that for m equals 7 and p equals 4. The term evaluate means to give a value to. So to evaluate, all we have to do is replace the variables in the expression with the number we're given for that variable. So 3m, remember, really means 3 times m. We replace the m with a 7, so 3m becomes 3 times 7. Plus 2p, remember, is also 2 times p. We replace the p with a 4, so that becomes 2 times 4. Once we have replaced the variables with the numbers that are given for them, this is now just an order of operations problem. We first do the 3 times 7 is 21. Then we do the 2 times 4 is 8. And 21 plus 8 is 29. We might have something like 7p plus 3m over 6d. And we're asked to evaluate that for p equals 12, 3 equals 8, and d equals 2. So again, our first step is to replace those variables with the values that are given for them. 7p, if p equals 12, that becomes 7 times 12. Plus 3m, if m equals 8, that becomes 3 times 8. All over 6d, if d equals 2, that's 6 times 2. Now again, it's order of operations. We have to do everything on top first. I'm going to write that off to the side here so I can do that. I start out with the 7 times 12, which is 84. 3 times 8, which is 24. And 84 plus 24, which is 108. So on top here, I have 108. Well, on bottom, I just have 6 times 2, which is 12. So I'm going to divide those out. 108 divided by 12 is 9. That evaluates to be a 9. I might have something like this, 6p squared minus 3p plus 2, and I might be asked to evaluate that for p equals 4. Now, everywhere I see a p, I replace it with a 4. So 6p squared becomes 6 times 4 squared. Minus 3p becomes minus 3 times 4, and plus 2. And now it's order of operations again. We have the 4 squared, which is 16. We have the 6 times 16, which is 96. The 3 times 4, which is 12. Then we're going to go left to right. 96 minus 12 is 84. 84 plus 2 is 86. So we can evaluate those expressions by just replacing the letters with the numbers given for them, and then just doing our order of operations. I believe I have most of your tests graded and they are posted. So make sure you're looking those over and doing any corrections on those. If you don't have your test submitted yet, please get that done today so we can get that graded for you. It is technically, it wasn't due until noon today anyway, so you still have time. Homework. There's 2 things out of the big book. Through page 382 through 384. Exercise 12-3. Problem 7 through 23. Also, then there's going to be a packet. I don't have it uploaded yet because I didn't get time to scan it yesterday with the in-services. I thought I'd get some time to do things, but had to shovel snow during my breaks yesterday. In this packet, it's going to be Unit 31, and I'll have you just do the odds on that part. I will have that packet uploaded by noon today for you. Any questions?
Do we have school Friday?
This Friday, there is no school. That's a good question. This Friday, October 23rd, I believe. Yeah, there are no classes on Friday. That's dual credit day, so that's the day that we have to communicate with the high schools to help them get some classes so they can set up classes so students can come to WITC with some advanced credit. So yes, we will not have class this Friday. Okay, we have about 20 minutes. If you guys would like to get started working, I'll be on the network here for a while.